On YouTube, we're back with the ASH26, and we just got done installing the motor. I did have to go in and trim a little bit from the bottom. As you can see, the gap is very tight. And one thing that was a little bit of a bummer on this setup is that even though you have a pretty good shape here, when you look from the top, because the oblong nature of the cone, you're never going to agree perfectly on both sides. So I kind of had to find the happy medium there. So what I need to do next is I want to kind of test the throttle just to make sure things are going to spin free. And if this doesn't work, I want to try to address it before I move on. So that's our next step. Just want to pop off this canopy. Still a little bit on the sticky side, getting that in and out each time because of the nature of the tab up here. But I'm just going to let that set up and it should be fine in time. Now, as you can imagine, in order to run this system, we're going to need to get the wires controlled so that they don't get hit by the outrunner and by the housing of the motor. And so the way I'm going to do that for now is just as simple as it can get. I'm going to put a piece of tape on it. But that's all the more I'm going to do for now. As you can see, this YEP ESC, it's already wired into the receiver. This YEP ESC is not overly huge. I want to make sure I get a good airflow for it. So I'm just going to plug this back in. Now I'm not really going to put this in here permanently. I'm just here for testing right now to get this hooked up. Ow! Cut my finger. So basically what we'll do is we'll temp this in here. And this is good to just get an idea of how much room we're going to need to operate these things. But we need to make sure it's in such a spot that when we run it, we don't have to worry about hitting anything with the prop. Just want to make those accommodations right now. We'll come back with the... We'll probably start with 2200 3S, just for size. But I'm going to go with a 60C pack just to be on the safe side. Alright guys, so we got the throttle cut on. We're just going to verify the throttle is going to be stuck down, which is what we want. And what we're going to do is we're just going to get everything in a situation where we can have control of this thing before we do our test. Our test is to ensure clearance here, so we have to test it with the prop. And that's just the way it's got to be. So I've got everything taped down just with masking tape. And then this is a good 60C pack, 2200 milliamp 3S. Okay, so we're going to let everything initiate. Okay. We have no servos hooked up, so there's nothing else to indicate that it's working. Okay, first things first, I'm going to cut the throttle cut off first. Okay. Nice, smooth shutdown. I'm actually going to grab some safety glasses just in case. Throttle cut is on and tested. In case something would get thrown. Everything else would get destroyed, but just not my eyeballs. Okay, so... blowing stuff around. % throttle. Just wanting to pull. Okay, so throttle cuts on. It's blowing my structure away. Even the structure that it's sitting on is trying to blow away. That's a good sign. That makes me feel good about the amount of power we're going to end up with. Doesn't necessarily make me feel good about why it's jumping out of my hand. So we'll just get this reset real quick. Now, throttle cut is on. Throttle cut's off again. One more test. Look inside. Okay, you know what we need to do? I'm going to just idle, just run this, just tractor the motor. There's like zero vibration on the motor itself. There's no vibration here, or an extremely little amount of vibration. That's why it's so quiet. Okay. Did you guys notice on this Yep, there's a red light? That's the presence of throttle signal. And what it does is it tells you when the throttle's engaged. So it's on now to the lowest setting. Then it's on. And then as you go back up through the range, the red light gets dimmer. And then when you cut the power, okay, so this is, there's 100%, and then you cut the power, and you see what it does? So it's this middle range. Okay, throttle cut's on. We have to test this with the canopy now. Okay, this will be the first test with the canopy. Throttle cut's on. In order to test this with the canopy, I have to ensure that stuff's taped down. I'm going to go ahead and just plop this in here loose. And at this point, for the test, it doesn't matter where anything goes. So it's just going to go where it fits, quick and easy. Okay? So it doesn't get damaged, of course. So, just dropping this stuff in here. Just like so. I'm just going to get this pack slid back here. And this is a very informative test, actually, now that I sit and do it. I'm thinking, geez, there's not going to be much room for a battery in here. Not by the time you put this thing on there. Because look, it takes up all this area down here. Okay, so we're sliding that into the hook. And we've got it latched. Wow, that's awesome. What a good feeling. Okay, throttle cut's off. I'm going to go real slow with the throttle. I don't hear any binding. I don't feel any vibration. That looks so sweet. If I'm not careful, it'll pull itself off the table, though. Whoa. Was that me? Throttle cut's on. Did that pop up because did it release? Or did I just never get it latched? I don't think I ever got it latched. Okay, let's try again. Something to watch for. Throttle cut's off. Full throttle. Okay. Throttle cut's on. Tested. Timer's cleared. Alright, I'm satisfied with that. I am going to right away grab this Allen wrench, and I'm going to sit here and tighten this down, make sure it's 100% where I want it now that I've validated all that. Okay, so she's already totally tight, so I'm not going to obviously break anything over it. But that's great news. So that means we can move on to the next step, which is going to be going ahead and figuring out some more of the electronics. So first things first, let's get power out of this. Power's out. 2200 3S, which, to be honest, guys, this pack is probably a little large for this plane. But I honestly don't know. I'd like to fly it on a 2200 3S, but it may not work. It may be too big. I got these 3000 milliamp packs. They're about another 20% longer, but they're very thin. They're about half as thick, and they've been working really good for me so far. So real excited about this now that we got that tested. Alright, plus this thing is it's not hot at all. It's like room temperature. So, the next thing I got to do is I got to start figuring out where everything's going to go. And this is where it starts getting scary for me, because I hate committing to these things. Okay, so the next step is, I think I should just get this stuff mounted. Because it's going to be harder to put the servos in if I have to dig them out to get this thing in. If I need to extend this, I'll extend this. But I don't think I'm going to have to extend it yet. So what I'd like to do is I'd like to have this underneath. Something like that. So I'm just going to let this, I'm going to see if I can get it to slip in. I do not know if it's going to make the angle. Not real promising looking. Oh! Not real promising, but it might go still. Okay, so it doesn't feel real promising. The other thing is, I never checked the motor's temperature. It's probably like 95 degrees. Just over room temperature. It's this S-back, always takes a lot of room. I wonder if I'm going to have to take and remove some of that material. The other option is I could take out the landing gear and slip it in from underneath on the backside, I wonder. Let's try that. Oh no, that's all mounted together, isn't it? Well, I think that's not going to work either. Now this is just the servo wire for the elevator. So I'm just going to move this out of the way for the moment. Just make sure it's not going to get... Oh shoot, it did fall in. We're going to have to grab that quick before it gets lost for all time. I'll pause it and get it real quick. Well guys, I had to run this piece of hard wire through. So the moral of the story is, don't do that. Don't yank your wires through on accident. And I'm going to make the best of it because it was an accident, obviously. And what I'm going to do is I'm going to turn around and go ahead and pull a push rod through. So that's what we're going to do real quick, and we'll just simultaneously get the push rod pulled through, because we got to do that at some point. Alright guys, so I got push rods here. I got this micro push rod set. It's 30 inches long. I don't know if it's going to be enough strength. I also have this, which is just a piece of steel. It's pretty strong once it's in a wrap, but this is not in a wrap yet. Here's another example. This is pretty sturdy too, but it's also quite heavy. So I'm really torn on the best option. Then we've got carbon fiber, which is very light and very stiff. And that's what I would lean toward, because then I can just take something more like this and just basically make one on each end that's then affixed to this piece of carbon fiber. And that gives us our freedom to move, and yet we're not running the weight that we'd be running otherwise. So I've got these carbon fiber rods ready to go. The other thing I can do is I can actually just take a variety, a combination, and just put this sort of thing on the end, get that out there on the rudder, and then allow that freedom of motion. So I haven't really seriously given this thought yet, beyond just kind of trying to put together a couple of different options. This one here has a little bit of a bind in the middle of it. I think it's because the rod might be a little dirty with some glue from a previous project. Or it's just a nasty cutout here. But I got to resolve that. It would be really nice if I could just use one of these. But I just don't know for sure if this is going to be strong enough. So This is supposed to be for lightweight, flexible, strong, ideal for indoor and park flyer airplanes. I don't know if this necessarily qualifies as a park flyer or not, but they're also, you know, the stuff isn't free. So the other thing I thought is if I did a push-pull system, meaning I did, or like a pull-pull system, however you want to call that, you could do one of these on the left and one of these on the right. Here's my dilemma at the moment. Plus these things are flexible, so you get a little bit of flexibility there. It's kind of handy. You can see if I size this up, you got your rudder hooked up here, right? I mean, you're barely going to make it out. So that's the dilemma I'm fighting right now. So that kind of keeps bringing me back to the same scenarios. The other thought I had was to go with something like this, which would be these CMPro 2.6 end rods. Then you could also use this thread awl, and I could just cut a little section of this thread awl, and I can mount it to the end of the carbon fiber to give me my adjustability, and then this would be on either end. So let's go see how far off we would be if we did that. See, that'll reach, and this is very light and very stiff. Then we won't have to support it as much, but we'll still probably want a little something to kind of keep it from flopping around in there. So you lose a lot of your efficiency if you let it flop around. This is CMPro 1/2A. I'm not sure what the difference is. In fact, this might not be CMPro. But either way, this is what I was planning on using on the rudder. So that's what I'm going to probably go with. So let me get this piece together and I'll come right back. Alright, so I took this tube here, and you can see about how long that is. It's not quite as long as this rod. This is the carbon fiber tube. So actually this is going to be the part that actually mates up with the control surface, which is going to be here. And then of course the servo is going to be, if I recall, it's this one for the rudder. And then this one I think is for the landing gear. I can't remember which one's which. 3104. Oh, they're the same. That's right. Yeah. Yes, 3104s. Look at the specs on those things, guys. So we can actually get that out and start figuring that out too. You can't ever just yank these things through the fuse, because it never seems to be quite that simple. Should hold down the weight. Now I only plan on using part of that to brace it at the front and the back. Okay. And as you can see, we've got a fairly sizable servo here. But the rudder on a glider does a lot. So it doesn't matter which side's which. It really truly doesn't. So I just need to pick one and be done with it. But it looks like this one might give me better proper alignment with the landing gear. So I'm just going to go ahead and put this one in here too. It's got to get in there eventually. This one's going to be for the landing gear. Let's see if we need any more. Oh, we got plenty of room in there. Plenty of room for that. Cool. Oh, we've got our linkage up here actually. So we'll get the other one for the landing gear. Again, same size. We got more of these plates if we need them, so we'll bring those in now too. So basically, these two servos need to have the wires brought through. Remember how we were fighting with that ESC earlier? The only thing that makes me concerned is that we're going to need some more room to get that electronic speed control through. So I'm probably going to wait to put these wires through that hole until the ESC goes through. because we may need to resituate things a little bit. And so, to make life easier on everybody, I'm going to just leave it where they are for now. Okay, so we'll just pull that lead back through here. That's for the rudder. And this one will be for, hypothetically, for the landing gear. Not 100% sure I'm going to end up using that yet, but let's just say I am for now. So I'm going to remember the one I don't need is going to have a quick knot in it. Okay. So now when we feed this wire through, we're going to also be feeding through the push rod. Okay. But the only trouble with that is I'm not 100% sure if I want that to go through or it's going through or not. But it's time to figure it out. So that means we have to figure out a couple other things too. Like for instance, if we're going to use this as the servo, am I going to make my angle? Well, it depends on what type of control adapter we use. Control horn. Let's see what they give us. We'll put them here so we can see better. See, these servos come with a lot of different things. That's really nice. This we already had. Normally I would use just the one that's got one of these because I don't need to do two and I don't want them in the way. Let's see what type of alignment we get. We're just sighting down the length. It's actually going to be pretty darn close to where we want it. So I would say that'll be our go-to. And then of course we got all these other little things. There's two screws like this, either of which I believe will hold in that control adapter. So we'll just get that put in there temporarily. Strange that they gave us both, but I'll take it. Now, you're probably thinking, why are you putting in that screw right now? Well, I'm just putting the screw in so I know how much everything weighs and where it's going to position. Obviously, when we hook this up to the receiver, it may change its home position anyway a little bit, and that's fine. We'll get there eventually. So, but for now, just spatially understanding where everything's going to line up, that helps a lot. So, the other option I haven't really talked about out loud is to just use a piece of wire and just do a bend. So it'd be a Z-bend, and then it would come up to here, and then we would use CA and heat shrink to make this one contiguous piece. And you know, I really like doing that, with the exception of maybe in this case, because then the quickest adjustment we're going to have is to lift it and move it, and move it. So using one of these threaded rods is nice, because you have some built-in adjustability. But am I going to get the right angle? That's the $10,000 question right now. Okay, so this piece here, this is $4, and these are $1.09. So either way, quite cheap. But the reason I'm looking at using this is because it comes with a piece of rod that is only threaded on the end. This threaded rod would be more... I'm just afraid it's going to end up causing problems, like it's going to rub on something or whatever. I mean, this would be fine for certain applications, but just maybe not for this one. So I'm going to lay that aside. We're going to go with the straight shot style, and then I can just cut them to length as needed. So we'll go ahead and get these opened up. I'm so not used to using this type of thing. I would normally just bend music wire and it would be just fine 95% of the time. But in this application I want just a little bit more robustness. especially on the servo that we're talking about, which is the on the elevator, excuse me, on the rudder servo, which is going to be quite critical for flight performance. So this will help to keep the slop out of it, if these line up, of course, which is the next big question. Okay, so now that we've got these installed, I'm going to go ahead and pull the second one out of this kit so that we can size up the holes by default. Of course, we'll cut off the extra unused portions. Okay, so we're going to open this up by unclicking that retaining clip. I want to go to the outsidemost hole, and let's see if it fits. It does not. So we're going to have to open this hole up, which is annoying, but I'd rather open the hole up than have the hole be sloppy no matter what I do. So I'm going to see what I got here. That's way too big. That's actually pretty close. We'll go one step down and see if that's... Nope, still too big. Okay, we'll go to 1/16. This is probably going to be too small, I'm guessing. Actually, that's perfect. Okay, so we'll just take this as our sacrificial test. We'll be using it anyway. So the one that we drilled opened, I'll mark. Now I don't have to mark them. Okay, slip this through. Okay, now it's through. The way I would describe that is severely limited amount of friction, meaning I should probably open the hole a little bit more. Even though it's in there good, and it's not likely to break free. I don't want to find out I was wrong. Okay, so nice cleaned hole. This is the time too where you're going to get your hose, your gas hose, or whatever it is you're using to hold these things tight on there. I got some right there. We'll see how this works. I can actually put that on the other side, to be honest. Okay, so that's on there. So now I'll see if this will slip on over the top. Not 100% sure if this is going to fit. If it doesn't fit, it'll just be too tight, or it'll break, which either one would be fine, as long as it does it now and not when we're flying. See, that's one of the reasons why I'm such a big fan of Z-bends too, is that they're the last thing to fail, you know. If you have a failure, it's not the Z-bend, it's like the wing breaking. Okay. Gotta slip this back a little bit so it doesn't cause a bind. Beautiful. Alright, so now we can start establishing some of our other distances. First things first, I know for a fact that I'm not going to do a push-pull if I'm using this size rod. So because I know that for a fact, I'm going to go ahead and cut these off. Might as well get rid of them now. We're not going to need the extra weight. It's not going to do us any good. You'll notice I'm starting with the opposite sides. That's because I could still do a push-pull right now. But not the way I've set it up. It would hit the landing gear. So we're committed now, so I'm going to go ahead and cut this off. That just shot across the room. That was awesome. Okay, clip the sharp edge. Sharp edge. Now let's make her pretty real quick. And we're getting close to running out of time here on this video. I'm sure you guys are getting used to that by now. Seems like about right about the time something starts happening. Believe me, I share your sentiment. Okay, good enough. So now, get that nasty little bump off of there. Alright, so we've got that ready to go. So that's going to basically go on there to replace the one we've got now, and that's going to give us our motion to operate the rudder. But obviously we don't want this going way back here like that. Not unless I could get away with two of them, and then it would still only be tempting, because here's the thing. This is kind of self-defeating because it's so heavy. Okay? I don't want to work with a heavy piece, which is the whole purpose of using the carbon fiber. Now the cool thing about the size of this is that it would also fit through the same guide. But there's no way I can put this together with this and still have it go through the guide. Okay, so I got to make a decision. Do I want to guide the carbon fiber, or do I want to guide the metal? And my rule of thumb has always been, if you're going to guide the rod, guide it as close as you can without binding the system. Okay, so in our case, you can see how this is going to be really close to this brace point potentially, but I don't think we're going to get away with that. We're going to have to go back here